Alright, hey everybody, welcome back to the Introductory Astronomy Lab. This week we're going to be going over Lab 5, the telescope. So to start out, let's give a brief overview of the history of the telescope, how it was first used in astronomy, and why it's so important. So initially the telescope was developed for warfare. It was used to kind of survey the battlefield, kind of get distances on objects that were far away, soldiers, encampments. It wasn't until Galileo came along that he decided to apply it to astronomy. Galileo used the telescope to make a variety of observations. His most famous, like we talked about in the lab report, are he was able to show that the moon actually was not a uniform sphere in the night sky, that it had a lot of craters, mountain ranges, ridges in it, and what this allowed him to do was to kind of show that just like Earth, where we have, a different topology along the surface, the moon also had that, and other astronomical bodies have that as well. What Galileo is most famous for, though, is his observation of the Galilean satellites, or the moons of Jupiter. And what this allowed him to do when he discovered these, when he, used his telescope to kind of look at them, it allowed him to basically prove that the Copernican model, or the model that the Earth rotated around the Sun and not the Sun around the Earth, while it wasn't a direct confirmation for the Copernican model, it allowed him to show that other objects in the solar system behave very similarly to the Copernican model. And a big part of that was that the Jovian moons, or the moons of Jupiter, did not revolve around Earth. They in fact revolved around Jupiter. Alright, so now that we've kind of gone over a little bit of history and why the telescope is so important to physics, we should talk about a little bit about the different types of telescopes. So if you were to go into a store or go online and look at telescopes, you'd see two main types. You'd see refracting telescopes and reflecting telescopes. Refracting telescopes were the earliest known telescopes. And basically, a simple diagram of a refracting telescope is, you have a big long tube, right, with maybe an eyepiece. We have our eyepiece, and we have our telescope tube. A refracting telescope uses a big lens at the front, known as the objective, and what that lens is going to do is take in all the incoming light and focus it at a single point, say inside the telescope tube. That light's then going to travel back, get reflected up into the eyepiece where it's magnified, and if you're looking in there, you'll be able to see your image. Now, the refracting telescope is one of the simpler designs, but it does suffer from a few drawbacks. Namely, the lens up front, depending on the size of the telescope, it can get very heavy. And when you want to scale these designs up into larger telescopes, it becomes very difficult to do that. They have overcome it slightly, but the second type of telescope that we're going to discuss, the reflecting telescope, actually improved upon this. Now, the reflecting telescope is similar in a way to the refracting telescope, but in that it still focuses light. But it goes about it in a very different way. Just like a refracting telescope, you're going to have a long tube. But instead of the eyepiece being located back there, it's usually located up here on the side. So light's going to enter your telescope, coming into the telescope, and in the back of the telescope, you're going to have a concave mirror. All right? And then in the center of the telescope, you will have a secondary mirror. So light's going to come in, reflect off of the back of the mirror, onto the secondary mirror, kind of like that, and out into the eyepiece. So essentially, in the refracting telescope, you are collecting and focusing light from a source. kind of magnifying into your eyes. Where in a reflecting telescope, the light is entering, it's being reflected, and then kind of collected into the eyepiece to where you will see it. Now, one of the main advantages to the reflecting telescope versus the refracting telescope is that these scale much easier than refracting telescopes. You don't have that big heavy lens in the front, you have basically mirrors. And when these get to be bigger, such as in a lot of research telescopes that they use today, and most telescopes that they use in research are reflecting, they can make hexagonal lenses, kind of like this, where they fit together and they kind of form sort of a matrix of sorts for the telescope. And so what essentially they can do, they can pile these mirrors together at the bottom of the telescope. So if you had a giant telescope that you were going to aim up at the sky, let's say here is your telescope, they can focus that mirror, or they can concentrate those mirrors down here and create a bigger convex mirror to kind of collect the light reflected to the secondary lens, and or secondary mirror, and out to a computer or CCD camera, something like that, that will record and collect the light. Now, the reflecting telescope was invented by Newton, and sometimes it's called a Newtonian telescope because it was originally invented by Newton. Since then, there's been a lot of other designs, namely in our lab at RCBC, we don't use strict Newtonian telescopes or reflector telescopes. We use a type of reflector telescope called a Schmidt-Cassegrain telescope, which is where instead of just a straight tube with a mirror in the back, it's split kind of like that. And essentially, light is, there's a center mirror here oftentimes. Light is reflected off the back mirror that's been split in half onto the center, and then out the back where you can view it through the eyepiece. So there are some variations on reflector and refractor telescopes. Now, one major disadvantage of a refractor type telescope is what's known as chromatic aberration. And that's where the light, if you were to shine a light through a prism, right, let's say this is our prism, and you shine a light beam in like that, it starts to bend the light waves, and they all come out at different angles, kind of like that. And that's when you can see blue up here and red down here. Well, the lens, the convex lens in the refractor telescope does that as well. And so a lot of times around the edges of your image, and so let's say you're looking through your eyepiece and you see an image like that, you'll start to see around the outside some of the chromatic aberration of that telescope. You can overcome that with special lenses in a refracting telescope, but overall reflectors are used because they're more inexpensive, cheaper to make, they scale easier, and they don't suffer from chromatic aberration. Now, on to our lab. So our telescope is right here, and it should basically be assembled just like this. All right, you're going to get it in a few pieces. You're going to have two eyepieces, which I'll take out right here, right, of different focal lengths. You're going to have your viewfinder, which you'll have to attach to the main telescope body. You'll have, let me just take that out real fast. You'll have your telescope, light enters here, it's refracted, focus at a point, comes out through this tube right here, through the eyepiece, where it's magnified depending on the focal length of the eyepiece. This one is a 5mm focal length, and the smaller focal length that you have, the more magnified your image is going to be. So let me just go tighten this back up again. All right, So once you assemble your telescope, it should basically look like this. All right? And what you want to do is first you want to pick an object maybe 20 feet away or so, somewhere like that, in your backyard, across the street, something like that. And you want to focus it with this knob until you can see the image clearly in the telescope with the larger focal length eyepiece. After you do that, you want to swap it out, put in the smaller one, and then refocus it to get your image back into focus. Now, once you do that and you learn how to use a telescope, once the instructions are in the lab manual as well, so check that out, read that thoroughly while you're setting this up. There's also online, I set some links for a list so that every time you want to set up your telescope and focus it, you can just go check that out instead of having to rewatch the video. But once you get it set up like this and you focus it on a distant object, you're ready to kind of go out in the night sky and start looking for things. Now, on Stellarium, they're going to give you two sets of coordinates for the most part. They're going to give you azimuth and altitude. All right? And the way that works in the topocentric coordinate system is just like our sky wheel, where you had, let's say you're standing in the middle of the field. Here you are. All right? You can kind of see the sky all above you, right? Let's say this is the north horizon, south, east, and west. The topocentric coordinate system is going to give you 2 degree measures. Like I said before, azimuth and altitude. Azimuth starts at north, 0 degrees, and goes around clockwise. 90 degrees at east, 180 degrees south, 270 at west, and 360 or 0 at north again. All right, so basically just starts at north, goes all the way around, comes back to north. So let's look for Mars, let's say. So let's erase this real fast, and let's look for Mars. All right. Now Mars is pretty cool, and it's fairly easy to see. It's basically almost directly south, depending on the time of day. So your azimuth in that case would be around 180 degrees. All right. Then the second quantity to know how high your object is in the sky is the altitude. So that starts at 0, right at the horizon, and goes up to 90 degrees, which would be directly above you. So in this case, Mars is directly south, and somewhere up here, maybe 23 degrees. All right? All of the coordinates are in Stellarium and online, the links I provided within the assessment. So these can change depending on when you're actually observing, the time of the night. So make sure you check that the time matches when you're actually out in the field. Otherwise, these coordinates will change. But essentially, you would, if I were standing right here and that was due north, and I wanted to view Mars, I would turn all the way around to south, or whatever my azimuth was, and then look up 28 degrees. And I would position my telescope there, just like that. I would find Mars through the viewfinder first. That's kind of like your first step. Put in the larger focal length eyepiece, focus on Mars, put in the smaller focal length eyepiece, and then focus again. And then you have essentially focused on and found Mars. Now, how do you determine these two coordinates? Well, there's a lot of different ways that you can do it. An app on your smartphone will easily tell you azimuth. It's just simply, whatever due north is, the degrees from due north, as well as altitude. So you should be able to pretty much easily tell those just from either a compass. You can use your protractor too. If you're having a little trouble, you can break this out and just put it at 29 or 30 degrees, kind of look up. And for a lot of the objects that you'll be able to see with this telescope, these they're pretty distinct in the sky. You'll be able to see Mars, especially if there's a little light pollution. Most of the stars will kind of disappear in a way, but Mars will be a very distinct red dot. Same with Jupiter, and obviously the moon. You're not going to need coordinates to find that if you look at the moon on the night of a full moon, but that's also very distinctive. Uranus is also out, although that might be a little harder to see. But just pick 5 objects from online or anything that you think you can easily see. A lot of the stars that we went over with the Skylab would be acceptable, and you're the Sky Wheel, and you already have their coordinates. If you want to check out anything else, Stellarium is a really good place to look. You can type in a constellation and just hit Control F once you open Stellarium at the same time and type in whatever you want to find. So if I wanted to, for my assignment, do Polaris, I would hit Control F. Within Stellarium, there'll be a search field that comes up. You just type in Polaris. And I think I spelled that right. And it should come up. So that's pretty much it for this lab. The instructions are online in the assessment. Just make sure you follow the instructions. You'll have a week or 2 to complete the lab. Depending on the weather in my area, I might extend it because I want you guys to have enough time to view the sky over several days. I don't want it to just be, kind of one shot and, well, I got my 5 objects and I'm done. So there may be an extension. All right, so good luck, guys, and I'll see you for the next lab.